Hello guys, very welcome to my YouTube channel. It's been a while. I wanted to discuss something about EVPN. Before this, I was never able to do EVPN on GNS3. I remember I have tried this once on iOS XR device, and at that time I was using iOS XRB, and with that particular device, I think there is a limitation that you cannot configure L2 VPN bridging on that device. That device is completely control plane device. So this time also, I forgot that I have already tried that. So this time I have started doing this. You can see all these devices here. So initially, I built a topology with all XR devices, and I was configuring everything. Everything was up and running. L2 VPN, EVPN peering was up. Everything was working. But the only thing I was not able to make it work was the layer 2 bridging. Suppose this is the CE router, or in this case, it is a switch. And for example, this is this device, which is for now PE1 XC router, but I was having PE1 XR router there. So, and I have configured this link as L2 transport link, and L2 VPN was configured on this one. The problem that I have faced is the MAC address on of the VLAN which was configured here was not learning on this particular router. And I found out that Cisco iOS XRV router doesn't support this data plane feature, and it was kind of a roadblock for me because I really wanted to do it on iOS XR devices, but due to this particular limitation, I simply cannot do. So I looked a little more and I found out that XRV 9000 devices may be an option to do it. So I tried that also, and there I was not even able to configure L2 VPN bridging. So after trying all these devices, what I got to know is that on iOS XR devices, on GNS3 at least, you cannot do L2 transport simply. So L2 transport is not supported. If you want some devices MAC address to be learned on your iOS XR device, that is not going to happen with the help of L2 VPN, L2 transport bridging feature that we have on iOS XR. So what I have decided is I have actually changed all those devices with my iOS XC device. Now this iOS XC device is CSR 1000V devices, and in the backbone, I still have one iOS XR device which is working as a route reflector. So normally, if you don't have full mesh IBGP, you would need route reflector. In this case, I have it, but still I wanted to have route reflector in my network because my network may scale. I just wanted to keep all the options open here. So that is the reason I kept this route reflector here. So I basically have two sites, two different sites. One site is this one, CE1 iOS, and another site is CE2 iOS. So on this CE1 iOS, I'm having multi-homing configured, and on this CE2 device, I just have single homes. These are just different implementations. So one important feature what we get from EVPN is we are able to connect our CE routers in this particular manner where we can have multiple interfaces going to different PEs, so that in case of one PE going down or one path is having some problem, the another path would still be reachable. And also it supports load balancing and lots of other features which are involved with this one. And this is one of the very important feature that we have in EVPN. So what I'm going to do is set up one baseline here so that on the basis of this particular baseline, I can build further videos to explain EVPN better. So in this video, let's just focus on the single home part of it. So let's get started. Okay, so let me start with PE3 XC router first of all, because that is the single home device. That is the only single home device in the network. And suppose you want to bring up a setup with both sides single home device. So you just need to replicate or mirror that particular configuration to other side of the PE router, and you should be good. And before I start going through the configuration, I also wanted to show you from where I have taken the reference configuration. So this is the configuration guide. I'm referring the Cisco IOS XC169X configuration guide. This configuration guide is basically dedicated for the single homing configuration. So you can see in this network, we have one PE here, one PE here, another PE is here. So we have three provider edge routers which are connected with different CEs. but all of them are single homed. So there is not a single CE which is having two PE connections for redundancy. So this is completely single home setup. And they have given some snippets of the configurations that you need to do on the router. And I have followed this particular configuration guide. It is working perfectly. Let's go through the step-by-step configuration. I'm going to enable EVPN over the IP MPLS network. I'll quickly show you the OSPF and MPLS configuration. So if you see, this router is having gig 1 interface, which is going towards the core, and gig 2 is the interface, which is the LAN interface. This is the gig 2 interface, which is going towards the CE, but gig 1 is the core interface. So on core interface, I have MPLS enabled, gig 1. So I have MPLS IP configured, and if you want to see the OSPF configuration here, there's very simple OSPF configuration that I have here. And on top of that, I have configured MPLS. So I must be having MPLS neighborship, etc. established. Neighbors. You can see that I have one MPLS neighbor. It is iOS XR device. Let me quickly jump to the other router, PE3 XC router. Let me show you the same. Show IP interface brief, exclude unassigned. So I have one gig 1 configured, which is going towards the XR router here. And if we see router OSPF configuration, this is also very simple router OSPF configuration. And I have show IP OSPF neighbor. If you want to see neighborship is up, show MPLS LDP neighbor. You can see that I have LDP neighborship set up as well. Now let's quickly go to the other router, which is PXR1 router. Here it is. Show run router OSPF. You can see I have enabled OSPF on all these interfaces. Router ID is 5555. Show IP interface brief. You can see that all of these interfaces are having IP assigned to it. And also loopback is configured. So if you want to see the MPLS configuration, show run MPLS LDP. You can see I have enabled MPLS LDP on all these interfaces. So this is the bare minimum configuration needed on XR to enable OSPF and MPLS LDP. And on all these XC routers also, I have shown you the configuration for the PE1 XC router. The same configuration is there on PE2 XC router also and PE3 XC router also. So if you are trying to set up MPLS LDP first, you can just replicate this part of the configuration in your topology and you should be good. Now let's move to the EVPN part of the configuration. I'll go to the configuration guide. In order to enable EVPN, first of all, you need to enable this L2VPN EVPN command, and you need to enable ingress replication and router ID you need to provide, and also MPLS label mode you need to specify. So basically, when there is no multicast based control plane, in those cases, we need to have the ingress replication enabled. So what happened in those cases is we will have a control session built up between the PE2 and PE3, and we are going to use that particular control session to forward all the traffic, for example, unicast traffic or bum traffic, etc. So since there is no multicast control plane here, so what is going to happen is if we are sending the broadcast or multicast traffic, it would be replicated at PE1 itself, and it would send the copies of those multicast or broadcast traffic to all the provider edge routers which are interested to listen to it. I'll get into more details of life of the packet in my upcoming videos. In this particular video, I just wanted to get started. Part of the configuration is just to enable L2 VPN, EVPN on the router. And here, if you see on this router also, if I do show run, I have this part set up. I have this part configured. And then iOS XE router gives you three options to configure EVPN instance. It can be VLAN based, it can be VLAN bundle based, and it can be VLAN aware. In this particular video, I'm going to focus on VLAN based. So I have replicated this part of the configuration. I have not assigned any route distinguisher or route target, because even if you don't do it, router would configure it for you. So it is not a mandatory part of the configuration. So I have just put L2 VPN EVPN instance, if you see here the configuration. And then after that, what I have done is I have the bridge domain configured. I have the bridge domain configured, which is bridge domain 10. And since this is PE1 XC router, let me just go to PE3 XC router because that is the single home PE device. I want to discuss that one first. So let me just quickly scroll through this part of the configuration we have already seen. And let's go to the bridge domain configuration. Okay, so in bridge domain, I have bridge domain 10 configured, and interface gig 2 is the interface which is going towards the CE, and the service instance which I have configured is service instance 10. And then you will have to assign the EVPN. Here we are going to latch or stitch the EVPN instance and the service instance that we have configured on gig 2. If you go to the configuration of gig 2 interface, you can see that I have a gig 2 interface where IP address is not assigned, it is just configured for L2. I have service instance 10 configured, and the encapsulation I have kept it as untagged. This is very simple part of the configuration, and that is all with respect to EVPN. Now the next thing is to configure BGP and enable L2 VPN EVPN address families on BGP. So with the help of that address family, we are going to exchange MAC addresses between these two different CE sites. So that is mandatory part of the configuration, and L2 VPN EVPN address family peering should be up. Then only we are going to have EVPN working. If I scroll a little down to the BGP configuration here, you can see that I have 555 router, which is a route reflector or IOS XR router. If you see the configuration on IOS XR router, you can see this is the BGP configuration on IOS XR router. I have L2 VPN address family, IPv4 unicast address family enabled here. And these three devices are the route reflector clients. And 333 is nothing but PE3 XC router. So on PE3 XC router, if you see, I have configured simple neighbor command and whatever we do to enable BGP between two hosts. So those things are there. The only new thing is this L2 VPN EVPN address family. This part of the configuration is very important. After that, there is nothing much which needs to be configured. You just need to verify if all the BGP peering is up. So I have route reflector configured. So I think I should be having BGP peering with the route reflector first of all. I'll quickly verify it. Show IP BGP all summary. Don't worry about this IPv4 unicast. I'm not going to use it anyway. I'm just going to use L2 VPN EVPN for this particular lab. So you can see that I have the peering. It is up since last around 3 hours, and it is also learning prefixes. So this part of the configuration looks good. Now what I have for the demo is I have one VLAN configured here on CE1 iOS router, which is having IP address as 202021. And at this router, I have interface. This particular interface is configured with IP address of 202022. So I gave the same network IP addresses so that we should be able to ping it over this particular L2 domain, what we have set up just now. So let's quickly check if we are able to ping or not. Once ping is working, I'll show you how that ping is working, how the advertisements are working, how the labels are getting assigned, and how the MAC address table is exchanged between these two PE routers and all that. So this is my CE1 router. Sorry, this is not a router. This is the L2 switch. And you can see show IP interface brief. It has one VLAN configured, VLAN 20, and it has IP address 202021. And this is my CE2 router, which is this router, and it has show IP interface brief. It has gig00, which is this interface, gig00 configured with the IP address of 202022. Now let me quickly ping 202021, which is the other side of the IP address. All right, excellent. If I trace it, you can see that it is like directly connected. It is replicated as a single broadcast domain, but it is going over the ISP network, but it seems like it is directly connected. So we are able to extend our L2 domain from this particular switch all across the ISP to this particular CE2 router. This is the kind of services we were getting with the XConnect, any transport over MPLS or VPLS. This is what we are able to achieve with EVPN as well. Let's try to focus and try to understand that how this particular communication is working. So if you see, first of all, I'll pick the MAC address from here and I'll try to trace the MAC address if it has learned all across the network or not. This is the MAC address on my gig 00 interface of CE to iOS router. If you see show bridge domain 10, this particular MAC address is learned over gig to EFP10. So, which is fine because this is a directly connected router. So, and it has a bridge domain enabled. So this MAC address should be learned here. But what about this MAC address? What is this MAC address? This particular MAC address is the MAC address assigned on the VLAN of CE1 iOS router, the VLAN 20. So if we go to this particular router and if you do show interface VLAN 20 IBIA, you can see that 8014 MAC address I was talking about, and on PE3 XC 8014 MAC is learnt over. It says that this is some pseudo port over which it is learned. It is basically learned over the BGP EVPN connection. We know that one of the MAC address which I have learned locally is there in my bridge domain, and another MAC address which is learned over the ISP network from some other PE. It is also sitting in my bridge domain. Now let's quickly see that how this MAC has reached here in the bridge domain 10. The only place from where it might have reached is L2 VPN, EVPN, BGP peering that we have configured. That is the only thing which is running directly between PE1 and PE3, right? So I'll do show BGP, L2, VPN, EVPN. All right, so it has learned so many routes that I see, but I am interested to know that this particular MAC from where it is coming. So if you just try to look into all these strings and try to find out where exactly this 8014 is, you should be able to find it somewhere. The PE2 router has advertised us this particular MAC address. Since this is a multi-homing setup, from here the packet would hash to either this interface or this interface, right? So wherever it is, the MAC address is learned, that particular router would advertise the MAC to the next peering. So I also have a peering between PE2 and PE3. So basically, the packet is hashed here, and as soon as this router has learned that MAC, it would construct a BGP update and send that particular MAC over this ISP network to PE3 router. And that is how we have learned it. There are a few more interesting commands available to check even further details about that MAC address, that what is the label assigned to it and all those things. The command is show route EVPN MAC detail. So if you see, it is telling you that the next hop is 2222. So this is basically hashing is happening. The packet may go to this interface or this interface because of the hashing. And in this case, it seems like it is going to PE2 XC, which is 2222. And once the PE2 XC is learning that MAC address, it is advertising it over the ISP network to PE3 router. So, but it says that it can be resolved via two next hop. One is 2222, another is 1111. So here, what is happening is this router PE3XE knows that CE1 iOS router or 2020-21 VLAN is sitting behind both of these devices because both of these devices are multi-home setup, and the Ethernet segment which is connected with both of them are same. So since it knows that Ethernet segment which is connected to those two multi-home router is same, that means 2020-21 IP address or this particular MAC address can be reached via both of these devices. So that is the reason the resolved next hop is both of them. So PE3 XC router can also do load balancing on these two devices. We'll see that in my next video. Now, with this information, I think we should be good with the implementation and verification part. I'll just quickly show you some packet captures. With the help of packet capture, we'll try to verify that how exactly the packets are getting tagged and what are the labels assigned to those packets and how it is working. So for that, I'll move to my GNS3 client. There is some problem in packet capture in web client. I'll go to my GNS3 client here. I'll start packet capture. So we have a packet capture running between PXR1 and PE3 XC router. Now I'm going to start the ping between CE2 iOS and CE1 iOS. I'll go to CE1 iOS and I'll ping 2020.22, which is the IP address assigned on CE2 iOS router. Okay, so I'll stop packet capture now and I'll see that what exactly is happening with these frames. This is the request. You can see it is coming from 2020.21 for 2020.22 IP address, which is on CE2 iOS router. And this is ICMP request packet. It has one label. This is just the VPN label because this is the penalty mate hop popping which is happening here. The XR router which is sending the packet is removing the transport label and sending it to the PE3 XC router. Now, what about reply? So reply is having two labels. One is 2400 and another is 16. So 2400 is basically transport label and this is the VPN label that we have. Now let me quickly go to the routers and show you the outputs that we have seen. In this output, we have seen that the label 16 is associated with 111 IP addresses. That means the response is going to 111 IP address. And if you further want to check the transport label, you can see that 111 IP address is assigned with the transport label, outgoing transport label as 2400. So that is how the response is going out. The PE3 is sending the packet back to PE1 XC router, and that is how it is working. I think that would be all for the single home setup. When I'll discuss multi-home setup, then I'll also discuss about bump traffic, that how bump traffic goes over the multi-home setup. So with this, I'll close this video. Let me know if you have any questions about this topology. I will see you in my next video. Thank you so much for watching. Please subscribe to the channel and happy learning.